Welcome to Spring LIB.
Yes, let's say there is a dike behind which there is water, and there's a little kid who's stopping, who's plugged in a hole in the dike with his finger. Now, if the height of the water level from his finger to the surface is h, then the pressure here will be rho g h. So for, let's say, a few meters of water, like 2 meters of water, this pressure will be rho g would be the weight density of water, which is 10,000 Newton per meter cube, times the height will be 2 meters, which will be 20,000 pascals. Now, if the kid has plugged in the hole with his finger, it means the area must be really small, about the order of 1 centimeter squared. So the force he needs to keep plugged in would be the pressure times area, which would be 20,000 pascals, which is Newton per meter squared, times 1 centimeter squared. And 1 centimeter squared is 10 power minus 4 meters squared. So that's about 2 newtons. And 2 newtons is a very reasonable force. 2 newtons is simply the weight of 200 grams. And a kid could easily lift a 200-gram lunchbox. So, yes, it's not a very unbelievable legend. It's just that even though he's holding back millions of gallons of water, millions of liters of water, the point is that the height of the water is very small, and this water is distributed over a very large surface area, which is why it's a very easy task. And that